In this video, we're going to continue working on the book and chapter code that we wrote. And what I want to do here in this video is really talk about maps. And a map it becomes very, very common in programming in all different languages. Sometimes the names are slightly different. Like in this case, they're called maps, what we're going to use. Another term you hear for them sometimes is dictionaries. But they're just wildly useful. So let me give you an example. And for this first example, I'm not going to do anything with our books and chapters. In fact, I can get rid of this. There we go. I'm just going to kind of make something up here to first demonstrate, and then we'll see maybe a possible way that we could use it in our books. But what a map is, it gives you, think name-value pair. So it gives us a way of assigning some kind of a key to a set of objects. So we could have, a list of, 100 different objects, and then there's a key associated with each one. So that when we wanted to go pull an object, if we were wanted to pull it out of the list by some key value, rather than loop through all of the objects ourselves checking them, we could just look it up by key. And let me give you an example that may help it make a little more sense. So I tried to think of a good example that might be at least a little bit interesting or fun. And for some reason what popped into my head were mood rings. Now most of you in this class may be too young to remember mood rings, but if you go back, certainly in the 60s and 70s, there was this concept of these mood rings, and it's some kind of stone. And honestly, I don't have any idea what kind of stone it is, but it's this kind of stone that you'd put in a ring, and when it came in contact with your skin, the stone would change colors, and it actually had to do with the temperature. But the idea was that the temperature, or the color of the stone, it would say what mood you were in. And the whole thing, of course, is obviously ridiculous. It was just measuring the temperature of your skin, had nothing to do with your mood whatsoever. But at the time, people thought it was, I guess, believable. And when you Google and you look up the different colors these stones can be and what mood that means you're in, what you find is it's not even consistent. But anyway, it makes for a good demo of this. So if I wanted to create, say we're writing a program that would take, you would say, here's the color that my stone is showing, and now you wanted to know what is your mood. So we could do that by creating a map. So let's go create val color mood map. Again, just trying to come up with a name that makes sense. So color mood map. And what I'm going to do is use a convenience function called map of. It's just built into the language, and it's going to create a new map. And the syntax here is going to be a little weird. So remember, it's name, depending on what you think, is name value pair, right? So name value. So the first thing is what's the name, or what's the key that I want to use. Well, in this case, the key is going to be the color. So when I pull the chart up, it usually starts with black, and I think that's the color of the stone if there's like no temperature applied to it at all. And when I look up on the chart here, if the stone is black, that means you are stressed. So the key is black, the value is stressed, right? Now this value in this case I used as a string. So I have a map that the key is a string and then the value is a string. But they don't have to be. Now typically the keys are either going to be strings or numbers. That would be certainly by far the most common. But on this side you see a variety. It could be, and it's always going to be an object, because in Kotlin everything's an object. But this could be anything. So in this case I'm using a string object, but later we'll create one and it will be book objects, for example. But in this case we're doing a very, very basic map that is string keys, string values. Okay, so let's throw a few more in so it makes sense. So if your stone is red, it means you are nervous. If your stone is orange, oh, what am I doing? Equals, sorry, wrong language. Okay, so let me go back. Sorry about that. In Kotlin, when you're creating these name value pairs for maps, you use the keyword to. I don't know why they did it that way, but I guess it does kind of make sense, right? Black to nervous, red to, or black to stressed, red to nervous, orange to, what's that say, unsettled. Yeah, so I've got a chart I just Googled. And what else we got? White to paranoid. And just do one more. Pink. Come up with something, yeah, pink. Something happy. Pink to cheerful. There, finally get something. It's a mood that sounds like it might be at least pleasant. Stressed, nervous, unsettled, and paranoid doesn't sound like a good time to me. But I guess it depends on what you're on at the time. Okay, so we have now this map that maps names to values. So now I can look things up pretty easily. So let's say, so in your program, you have a color reading, and somehow it's able to go out and get the color off of the ring. Well, I don't have a way to do that right now, so we're just going to hard code it. So let's say your ring is orange. So if my ring is orange, then now I can get the value out of the map just by saying val mood equals color mood map, and then the key, and I'm going to put it in brackets just like you would an array, color reading. And if I do a print line on this, you'll see that we have of mood that I looked up orange, and orange is going to be unsettled. So if we run this, we should see unsettled print. There you go. So they're really, really useful. I mean, in this case, it's a little silly. Typically, these are more complex objects that you're mapping it to. But when you have keys and you're frequently looking it up, this is a much, much better way, as you can see, right, than writing loops and doing it yourself. Now, in reality, yes, it's, well, actually, I guess I'm not going to get into that, but dictionaries, they're pretty interesting, and how you can have a long set of data and efficiently find the data inside that set gets very, very, very interesting. I don't know if that's something you guys have covered yet, or even if it's something that you will cover in your undergrad, but it's a fascinating subject. Because one way to do it is like what you might have done if I asked you to go through an array and find the right value. You would probably loop through it one at a time until you found the right value. The problem is that's very inefficient, right? You will have to, on average, loop through your data, to the halfway point on average, right? Which is not very good. And sometimes you're going to go all the way to the end, right? So sometimes you're going to hit somewhere between 1 and n number of loops. So on average, it'd be the middle. But there's a lot better ways. For example, hashing, where you can kind of hash stuff down into smaller buckets. But again, I'm kind of getting off the subject, so I will stop. But let's go up here and say, maybe the color was green, right? And we don't have that in our map. So you should ask yourself, well, what would happen? What would happen if it's green and it's not in our map? Well, what happens is we still get a value back, but in this case, it's going to be null. So just something to know, that the value you get out of your map is an optional. So just be aware of it. Again, when we're just doing print lines, it doesn't really matter, but when you write your real code, you'll have to know that there's a possibility I could get an null back. So, maybe this is a good time to do a refresher. So if I want to print something out in my program, I wanted to use the, this mood thing, and I wanted to display, here's the mood. Well, I don't want to display null, right? That doesn't really make any sense. So this would actually be a great opportunity to use an Elvis operator. And maybe, your mood is unknown, right? So if it's a color we don't recognize, we default the value to unknown using remember, the Elvis operator. So if I run now, it will say unknown. Okay, so there's map. And since I'm going to give you guys, I need to update and give you guys a copy of this code. Okay, so this is an example of a static map. And so what I mean by static map, when I create a map, it is immutable, meaning you can't change it. So these are the values in the color mood map, and I can't add new values to them. A lot of times where we see this, and where this comes up, is when you do have, that there's a set amount of data, and that's all the data that there's ever going to be, and so this is what you have. But if you need something more complicated than that, then we need to do something else. So let's say we want to create a library. And a library is made up of books. Right? So we do library. And again, I want to create a map, but in this case, I want to be able to add books to it, right? In my software, there's some part of the software where you can create new books, and I want to be able to continuously add books to my map. This isn't going to work, obviously, right? But the problem is map is immutable. We can't make changes. Well, what comes to the rescue is mutable map of. So mutable map of will create a map, and in this case, I'm not using any data to start with. It's kind of like our array list. So it's going to create a map that's going to be empty. But also, when you create maps, mutable or otherwise, you do need to tell it the data types. What's the data type of the key? What's the data type of the value? Now, the astute student will look up here and say, but you didn't tell me up here. We didn't say data types. Well, that's because it got inferred, right? Because this is all static, it's able to look at it and say, I got a string for my keys, and I have a string for my object. But since I'm creating an empty one here, I'm going to have to specify it. If I try to run this right now, I'm going to get an error. Right? It's going to say, hey, you got to tell me what kind this is. The error doesn't make a lot of sense when you first read it. It's kind of one of those error messages where you kind of already have to understand what the error is to make any sense out of the. But what it's telling you, look, not enough information to infer a type variable k. This is just shorthand that you see in documentation. But so what you need to do is just use the brackets just like before. If you remember up here somewhere, I don't remember exactly where, but where we created, oh, there it was. We created an array list. We said this is an array list of chapters. So down here, we're going to create a map, but instead of one value, I need to give it two. So the first one, what is the key? So for our library, my key is going to be a string. And what I'm going to do is I'm going to make up strings that we're going to pretend like is the Dewey Decimal value. And then the value that we're going to keep track of, those will be a book. So now I've created a mutable map that allows me to add to my library a book and give it an a Dewey Decimal number. So to see what that would look like, I could do library dot, and I got to remember, was it add or append? And again, this is one of those cases where different languages do it differently, and I'm always going to forget. For the life of me, I don't remember, so let's just do it and see. Okay, so hopefully I remember this right. I believe in Kotlin, I can just do this. 1, 2, 3. Let's say our Dewey Decimal number is 1, 2, 3, 3, 2, 1. So I just give it a key, and now I can say it equals something. And in this case, if you remember, we created a book object up here. Right? So I'm going to go ahead and add that book. And let me just run this real quick, make sure I got my syntax right. And I did. Now there's no output, so we didn't see anything, but it didn't crash. So we can add items just by, in the brackets, putting the new key, saying what it's equal to, and now it will add it to the map. So let's create another book just so that we can have a couple books in our library. So let's do another one. Val, we'll call it, Harry Potter 1. Okay, so it is a new book, and the author is J.K. W.L.I.N. Rowling, and the title is I should have picked something I know how to spell. Okay, these S-O-R-E-R-E-R-S, Sorcerer's Stone. I have no idea if that's right, but that's okay. I'm not going to bother adding chapters to it. You guys have seen that. This is just so I can add things to the library. Let's do one more. Let's do Val. Armor is a new book, and the author is John Steakley, and the book's title is Armor. And now I could go through and say library, and then I need to know what is my ISBN. So for Harry Potter, I don't know, we'll call it HP 889-24. So I have no idea Dewey Decimal numbers, what valid ones will look like. I haven't had to look at those in many years. But this will be Harry Potter 1. And then we can add another book to our library. RB library, and maybe the Dewey Decimal Number is QWERTY, and that is we're going to assign that armor. Okay, so we now have a library, and our library has 3 books. I can always ask the map this comes in very handy. I can always ask, how many do you have? So if we run this, we should see 3. Right, so we have a count of 3. There's 3 books. And you can always grab them. So if I wanted to say now val b equals library, and then let's do armor. So our key is QWERTY. And now if I say print line Q, or B, we should print out the information for John Steakley's armor. Oop, somewhere I got a typo. Let's see, library Q, oh, I didn't do the key right, so I typoed it. QWERTY, there we go. Now when I run it, we get the output, and I see there's no chapters, so we didn't print anything out, but we get John Steakley, who wrote the book Armor in the early 80s. As a kid, that was my favorite science fiction book. Okay, so there's maps. They're super useful. Anytime you need to be able to look things up, you're going to have a large list of stuff, you want to be able to look things up, a map is a really good way to go. If you don't need to ever add new stuff, you know exactly what you're going to have at compile time, then you can use a static map. Works just fine. If, on the other hand, you want to be able to dynamically add or remove things from your map, you use a mutable map. So again, this thing comes up over and over again about being mutable or immutable. And it's something you just need to think about in your program. Do I need to change things? Do I not? Okay, so enjoy, and you'll see in your homework on one of the assignments, I even explicitly say, this problem is a good problem to use a map. And specifically what I was talking about there is a very simple map. You'll use a map similar to this, but instead of mapping out of mood rings, you'll be mapping out, I'm trying to remember what the problem was. Taking a numeric number and turning it into its English equivalent. You can use a map to look things up to make that problem much simpler, and the whole problem can be solved in a dozen lines of code. All right, so with that, I'm going to end this video. Thank you.